Hey everyone, and welcome back to our educational series with the Women of SWPA. I have Rana with you today, and she is going to talk to us about flushables. I know there's a lot of different terms out there that we can use. That one's easy for me to really understand, but I'm really excited to learn from you today, Rana, and the whole group SWPA, the Submersible Wastewater Pump Association. Just amazing group of people, really focused on education and training. And so you're doing a lot there, both on the website, through on demand, as well as these hands-on trainings. And we're really excited to be able to see you at EPIC in November too. So at this time, I will turn it over to you, Rana, and I'll be here.
Thank you, Charli. Thank you for the nice introduction. And thank you, everyone in SWPA. Yes, I've been dealing a lot with SWPA for a lot of educational programs, especially in their meetings. So today's topic, we're going to talk about very important things that's happening everywhere, which is the non-dispersible consumer's product. What does it mean that? And we're going to talk about effective methods to eliminate the clogging of the solid handling pumps. So what does it mean, dispersible? So here is today's agenda. We're going to cover background, so we give you an idea about what is this dispersible. We're going to talk about the new wastewater, and then we're going to cover that with some of the solutions and effective methods of developed to avoid having the clogging in the solid handling pump solution. So I'm going to start right now with the background. So what is the background? Give you a hint of background, what we are talking about. So back then, in the days of the 1990s, we were talking about utilities experience pump clogging, okay? So what does it mean? And what is the consumption at that time that mandates? So back these days, and to the end of 2000, consumers been starting to using lots of products from non-woven sheets to everything else. And then we started to see that lots of items get thrown away: baby wipes, cleaning, waxing wipes, you name it. Even the kids right now, they throw everything in the toilet. So consumers began to employ toilets as a trash can. You will see everything goes to the trash can. So the sales of the consumer of non-woven sheets becoming explode at that point. And that's becoming a significant increase in modern trash. That coupled with reduced liquid content that goes to the sewer system, and that's becoming very lethal. So EPACT, what does it mean, EPACT? EPACT is an energy policy act that introduced by the US government to reduce the energy conservation and to maintain the renewable energy. They mandate that in 1992, that 1.6 gallon, which is almost 6 liters per flush, is required or less. It's also mandate that low flow shower heads. Now, even the waterless urinal for the men in the bathrooms, less water while solid components increases. And then they also mandate that for the toilet manufacturer to promote flushing powers. So you don't have to use lots of water when you are flushing. Exhibit flushing of urinal system, and no concern shown for collection system. So this is the mandate by the Energy Policy Act back then. What does it mean that impacting the new and wastewater? Okay, sanitary wastewater consisted primarily of used water or potable water that is discharged to the sewer through the plumbing system, residential buildings, industrial and commercial establishment wastewater. And any sanitary wastewater can also contain an inflow from the rain, the streets, washing, and so on. So all of these is what we call it sanitary wastewater. As you can see from this picture, you're going to see that lots from new product that's coming in and can be used in the flushable systems. The toilet paper, the diapers, the wipes, the cleaning wipes, the tampons, everything. That can be what we are referring to as non-woven. So the innovations is in consumer product and consumer behavior have presented many challenges to utilities. Over the years, this has become more and more and more. This is some of the activities that you can see recently on any of these non-water. You can see by the unit, and it's going to show that it's a very safe for baby, very safe for pets, for grandpa, for you, for the toilet. And this is what drives that problems, that you are buying right now all these products, and it's you assuming that it's a very safe for our collection system. So the problem is growing over the years, growing even more with other stuff that now you can add the fats, oil, grease, which is what we call it fog, into the mix. So now we have a dispersible and fog. So now we have no non-woven material that's added, fog materials added, and also any product that can be thrown away. As I can say, whatever added in, it can be thrown away. So traveling through that collection system, you can see that fog, great biological material sand. This is adding surface tension of the non-dispersible is increased. Material is easily combined and built into large masses. There is another organization as well is managing this. It's called the INDA. The INDA mission, which is the association that's responsible for non-woven fabrics, has a mission, say that, it's promote the value of non-woven industry worldwide. We monitor, analyze, and influence trends that affect this industry for the benefit of its member. That mission is being presented in the WOW, which is World of Wives Conference, International Conference. And this is dedicated to what we are doing as an organization to promote that this product for non-woven is safe to be used in the collection system. So what ENDA did as well is promoting and showing how far the consumer has been using these non-woven products. If you look to the chart in here, back to 2011, the sales of the non-woven started about 9 million. If you look to today's date, which is 2021, we almost doubled. So I went up to 16 million. And this is only the consumers without the industrial. Adding the industrial into that, and we are now up to 20 million. So this is a huge, incredible increase of the using of that non-woven product over the year. So also the ENDA have made a chart and say, they analyze what can be used and what cannot be used. So they said that, is this product constructed from non-woven are safely to be used, okay, and is also to be used as a flushable? If not, then it's not within our scope. If yes, then it's gonna go to the next step, which is this product designed and marketed for commonly used in the bathroom setting or for toilet purpose? If it's not, then there is no potential risk into that, and we can just use a label of a discretionary to say that it's not to be used in the toilet. If it's yes, then it goes to the next step, which is in normal use, could the product become contaminated with feces, menses, or urine and germs typically associated with the sewer system? If it's no, then there is no significant potential to the dispose. And again, we need to use the label, which is do not flush. If it's yes, then that means that it's a significant potential to be disposed to the toilet. Now we came to the point that, yes, all these products are subject to be disposed in the toilet. So what we can do then? Then if this product is disposed to the toilet, it has to go to a certain test, and they have dedicated 7 types of tests to technically proven that these products can be easily flushable and easily to be consumed within the collection system. If it did not go through that test, that means that it cannot be claimed and cannot be thrown into the flush system. So this is what ENDA has been doing to assess the flushability assessment for any product that's need to be introduced to the market. What is impacting all of these is the high cost of clogging. Once you have all these material enter to our sewer system, then, and if it's clogged, it's create huge problem, and it's unlimited. One of them, it could be the sewer overflow. And once you have a sewer overflow, that's a major issue. It's impacting customers, streets, end users, everything. You have a customer backup, so you have a health safety issues. You have also endured the cleanup cost after that mess. Maintenance cost, of course, for those equipment, have anything in the road. The fine imposed, you as a consumer, house owner, building owner, assuming that you're going to have all these sewer coming to your property, damaging, you're going to have a fine against the utility. The cost of the repair, those damaged items of the equipment. The service interruption, now you have no service. You already have to stop everything, clean all this mess, and start repairing all the product, go back again to time. So all this is service interruption. Equipment downtime. And at the end, of course, which is a very important, customer satisfaction. Like if you are you and me, and I'm going to have the sewer come to my house, I'll be disrespected at all. Okay, I'm going to demand the utilities to pay for all the damage that I have. So you can imagine how much of an impact to have a clogging because of non-woven cakes stuck around the items. I probably have seen some of these pictures. Okay, so you can imagine how it's big, it's the clogging in. So this is some pictures of the impellers. It's showing some of the clogging. So when you have the impellers for any pumps, whatever the type in is clogged, that means that it's reducing the hydraulic efficiency, increasing the operation cost. You have unbalanced loading. It can also impact the shaft and bearing. That means that you can lead after a certain time of running to damage the shaft and the bearings, and increasing the maintenance cost. On the next slide, I will show you some of the pictures that impacted with the clog. You can imagine how severe is this clogging in. And as I said, it doesn't matter what type of impeller or pumps in. Clogging is a clogging, okay? It's accumulation of all these materials over the time that can create clog, stop that in pumps to be working on, and then getting to the sewer flooding. You can see here from this picture, the amount of woven that's already been sitting on the impeller end. And that's not only impacting impellers and pumps only, it's also impacting a lot the system itself. See here, I believe this is one of the severe pictures. You can see the amount of non-woven coming in on top of the pumps that the technician has every time. The operator have to remove the pump and remove all this rash and crash. It's not only pumps, valves, screens, pipes. So imagine how this is going to be impacting any of the system that we are trying to, the sewer system, and the amount of work that dedicated to clean out all of that. So the challenge from non-dispersibles item is they are all strong fibrous sheet structure. They are non-dispersible, act as a filtration product. The sheets in collection system filter can be contained of any of the fog, biological material, great sand, sheets, surface tension greatly increased. So what we are saying, and this is very common to say, fog, which is the cement, wipes are the bricks. So you added those two, cement and bricks, and now you are stopping any sewer system from being working properly. So this is in a system. But if you look deeply into that, impeller clogging phenomena, you know that anything that we need to transfer has to go through the pumps. So the impeller in here has a very big fact there. So the phenomena when we have that impeller clogging, so if we are using traditional solid handling impeller vane, then you will have that the vertical leading edge catch the material. Adding to that, additional material agglomerate. Passage of solids is diminished. Efficiency reduced. It's going to have high power. Creation of unbalanced load, leading at the end to pump to stop. If you are using impeller mounting nuts, any sharp edge can catch any trash. If you are using enclosed impeller hub, the abrasive wear can open the wear rings interference. Semi-open impeller clearance. Do you have a clearance right now? Any clearance can take any of these trash to clog. So I'm going to show you on the next slide is when we have that clearance in or gaps in between the wear rings and impeller and how easily can take any of the rash. And that's going to create unbalance because the material flow from high pressure side to low pressure for the inlet is going to sit in there. The wear ring interface area can clog with trash and increase pump using power. So the power right now, the pump is trying to pump and pump, so you're going to have higher power in there. So what can we do when we see all this type of trash on the pumps? So now we are simply do not flush non-woven sheet. Okay, so we will always say that reduction of non-dispersible loading, you have to do improved product that can actually disperse, improved product labeling, public education, regulation, and legal action. And is the most important part is here, do not flush. So if we keep educate the public, educate everywhere, so do not flush. This is a very important part in here. We will reduce or eliminate the amount of trash going into the sewer system. What we can do as well is, so this is on the public side. Okay, on the other side, which is the manufacturer of the product, is we handling of non-dispersible product. So we can have adding trash baskets, pump station grinder screening system. We use of the grinder type of the or commutators, which is grindly find the anything comes in. Fine screen, although a lot of operators, we don't prefer the fine screens because of the more work is dedicated to clean those screens. Conveying of non-dispersible products. We almost that we asking for using of a shopper pump type or modern technology for handling the solids. We are using different type of control, okay, and that type of control can dedicate it that whenever there is a sense of clogging coming in, of there is high power, is to stop and giving alarm to the operators to go and check before the pump even to stop on the system. So this is some, and we have a lot we can add it in here on the control. We can have the control system that can operate the pump on the reverse direction to eliminate the clogging and get the pump to work back again. So it is also giving you a monitor device for the pumps that there is a certain time of the day, we're gonna have an influx of modern trash. So we can work onto that. So there is a lot can be done on what we can do. Not only on the pump side, but also on the whole system. Okay, we can add a trash basket, pump station that has a grinder screening system. That's when the influx coming in, it goes directly to the grinding. So it's grind them to very fine materials that help the pumps to pump them out. We can add the commutators that can be trashing everything very small and very fine screen as well. And as I mentioned that before. So this is all helps, but also the design of the pumps impeller, that's also another factor that can help reduce that. As I mentioned earlier, the shopper type pumps, it's a very commonly to be used on this type of applications, or the newer technology of impellers that handle the solids for the coming in of the pumps. So this is to give you a bit of idea about all the modern trash and what can be do for solving that. On the next slide, I will be talking about what is the effective solid handling pump solution. And this is only dedicated to what type of pump solution that can be effectively handling the solids. So here it's going to give you a table to explain to you what is the terminology. When I say that, what does it mean non-clog or solid handling? A definition to each one of them, the technology, the action, pros and cons. So if I focus more on the solid handling non-clog definition, it's a very common terminology on the pumps. It's a very common to be used also in the sewer system and solid handling. The most common impeller that's been used on the solid handling is the vortex, the channel, which is closed impeller, screw impeller, grooved suction cover, and back swept impeller. The purpose of this technology is solid passed through the pumping actions. Okay, so it has all an opening that can be passing the solids. The pros for this solid handling is product and size range, flexible configuration, efficient design, high efficiency, wide, and can be helping a lot with passing larger size installation. The cons for this type of non-clog is depend on the flow rate. If the lower flow rate would have lots of solids coming in, it might impact and might cause sedimentation and clog. The next type of the pumps or the terminology is the cutter. So you have an impeller designed together with suction cover that already has a cutter mechanism. This is similar to the slurry application, okay? It's addressing the rag and clog hydraulic efficiency. It's usually working with a large solid, doesn't work with a large solid. That means that it's not gonna have a big impact on the large solid. If I go to the next one, which is the shopper, which is a very common to be used in this type of application, is fixing cutting bars with a rotating element before impeding. So you have the cutting edge, then it's gonna cut, and it goes to the impeller right away. This is the action that's made from the shopper is to reduce to slurry or random sizes particles. So it's gonna cut to eliminate the bigger clogging or bigger chunk, and it goes to a smaller item that goes to pass through the impeller. The pros for this one is a very robust design. It's handled heavier and harder solids. It's a moderate Q and A also range. However, it's a very less in efficiency. It's a larger power, okay, because you need to have a higher torque in their requirement. The MPSH they have here consideration is going to be very high. So that's the requirement. However, if you talk about what is the efficiency between passing all these solids versus the efficiency, you will go towards passing all these solids and getting them passed on rather than clogging. Then we have the grinder. The mechanism in the grinder is a suction port, single shafted mechanism. It's a single or double shafted commutators. It's also cutting in. It can be cutting into a slurry and consistent with a small particular size. Its widest range of handling at source. However, it's a very narrow in range. Okay, so the Q and H is a very small. It's not large. The screen is needed. So you still have the ability to have a screen coming in before that. And then you have the option to cleaning the screen every time before go to the grinder. So this is at the best the definition for what is being used in general in that type of situation. So in the next slide, which is we're going to talk right now here about, if we are talking about solid handling pumps, okay, what type that we are using in here. And here is more of an illustration picture to what we are giving on the illustration before. So we have the screw type design. You see here, so it's going to have the screw. You have the rags going around the impeller so they can pass on. And then you have the resistor type impeller or the innovative back swept impeller. So you have the back swept, so it can be trying to get that rags on the back vein rather than stuck on the front vein. So those impeller design consideration have a very big impact on the flushable materials. So we have current state standard. So we have a standards being given in here, and it's recommended for the standard for the wastewater facilities. And it's mainly saying that pumps handling raw wastewater shall be capable of passing solid sphere at least minimum of 3 inches in diameter. So this is one recommendation. It's been already mandates. Exceptions to the requirement may be made when the pump design include equivalent protection from clogging. Okay, so if it's been designed and saying that it's going to be protect against clogging, then that's going to be another also exceptional to the recommendation. semi-open impeller design in conjunction with grooved suction cover facilities can also be working. Instead of they say that this impeller is designed to pass the 3-inch. No, we have certain impeller design is not designed by the size, it's designed by the way that is impeller grooves are made, so it can pass all the trash in it. So it's not necessarily by the size. So as I said in here, the design of the impeller is a very big impact on that flushable. So we said that the modern impeller design technology has a semi-open impeller in conjunction with grooved suction, like this one. It has a grooved suction, cover facilities movement of solids, or assist in prevention of impeller clog, which is going to have an assistant in like this one or this one. So going back again to what we can do, remember when I spoke about the control, the PLC, which is programmable logic control. And it can be programmable logic control, it can be a remote logic control, it can be any type of control that is designed for anti-jamming features. So whenever you sense there is a jam coming in, it's going to be preventing and stop the pumps and rotate. So it's going to be having the sense of impeller clog. That's a very good features for the pump. So you feel that, the pump will stop, or you give you alarm. The operator can step in and work with the pump. Pump unit execute as a preset number of forward and reverse operation. If jam is not cleared, alarm is then set, and then operators will come in. If we put all of that together, okay, if we put all the dispersible issues together, the design for the public, what to do with the public, and what to do with the factory, what to do with the flushable materials. If we put all of that together, we say that the non-dispersible issues continue to grow. The public education has a limited benefit. Modern solutions have proven to deliver maintenance saving, eliminate pump unit clogging, reduce maintenance call out, deliver operational saving, and we would like to talk in here more. Deliver operational saving is a very important. The more you save into that product from having repair of the product or reduce the amount of call out of the flooding, this is an important part. So you are reducing energy consumed as taxpayers. So we don't have a lot to pay a lot of energy cost here. The bill will not going to be that high. Increase long-term efficiency, and then your equipment can stay for a long time, so we don't have to pay as a taxpayer again for another equipment to fix it. And then each utility must determine their best practice. So this is to put all together is what we can do for the flushable items. And this is to conclude my presentation. And if you have any additional questions, feel free to reach out to me or reach out to SWPA and Empowering Women as well.
Thank you so much, Rana. And you have one more slide on there that I want to talk about for Empowering Pumps and Industry Conference. That's coming up. That's November 8th and 9th at the Water Tower. We're so happy to have the Women of SWPA there teaching us about, yes, grinders, choppers, pressure sewers, and also smart water solutions. So he talked a lot about controls there. And I think I wrote down some notes on a couple of different things that I've learned. But I'm excited about that, excited about partnering with SWPA on that. And getting to see everybody again in person. That's always a great time of connecting. So thank you so much for your time today and helping us get a handle on this. And it's funny to start the presentation, I said flushables, but it really should say non-flushables, right?
Yes.
If you have a question out there, the answer is do not flush it. So we cannot stress that enough. And I think that it's great that we have all this technology, but to put it back on the consumer as well, to look at your own habits. So thank you again for your time today. And I look forward to seeing you soon.
Thank you.